Welcome to PSN College of Engineering and Technology Media Center. I am Madan, Assistant Professor, Department of Mechanical Engineering. Now I present the Kinematics of Machines. First of all, the basic of mechanics. Mechanism is a science that deals with motion. The mechanisms, there are two types of mechanism. First one is statics, another one is a dynamics. Static is a system which are not changed with time, but dynamics is a system or change with time. Example, static is a structures, dynamics is a motion. Next, kinematics. Kinematics is a deals of motions and time, but is not considered for force. But kinetic deals with motion, time and force. Already discussed, kinematics is not considered for force. Kinetic is considered of force. For the example, statics is a structure, kinematics is a mechanism, and kinetic is a machine. Next, structure. Structure, a single body with no motion, combination of bodies with no relative motion. There is a rest of body. And a mechanism, a device to transfer or transform given input motion to specific outcome motion. It is a mechanism. Machine is a device to transfer or transform energy to do useful work. So structure is a rest, mechanism is a transfer of motion, and machine is useful of work. It is called as structure, mechanism and machines. Next, what's the difference between machine and structure? Already we discussed, structure is a rest, there is no movement, and machine is a movement of motion with related to work. The following difference between machine and structure. For few points we discuss machine and structure. First, a part of machines move related to one another, whereas the member of a structure do not move relative to one another. So structure is not movement, and machine is movement to useful work. Next, machine transform the available energy into some useful work, whereas the structure no energy is transferred into useful work. Another one, the link of a machine may transmit both power and motion, while the member of a structure transmit force only. Next is a kinematic pair. So already we discussed, kinematic means deals with motions, time, and without consider of force. So now the two link or element of machine, when it contact with each other, if the relative motion between them is completely successfully constrained, that is, it is called as, this pair is called as kinematic pair. For example of kinematic pair. So when the motion between a pair is limited to a defined direction irrespective of the direction of force applied, then the motion is said to be a completely constrained motions. It is called completely constrained motion. For example, the pistons and cylinder we consider from a pair. Cylinder and piston is one pair. The motion of piston is limited to a defined direction. The related to cylinder is irrespective of the directions of motion. Next, incompletely constrained motion. For example, its incompletely constrained motion is maybe either rotate or slide in a hole. This both motion have no relationship with the other. Next, successfully completely constrained motion. It is when the motion between the element forming a pair is such that the constrained motion is not completed by itself, but some other means when the motion is said to be successfully constrained motion. It is called successful completely constrained motion. Next we discuss sliding pair and turning pair. Sliding pair. When the two element of the pair, already we discussed a pair. So when the two element of pair are connected in such a way that one can only slide relative to other, this pair is called a sliding pair. For example, piston and cylinder. It is a completely constrained motions. Is a sliding pair. Turning pair is an angle. Okay, this is an angle means when the two element of the pair are connected in such a way that one can only turn or revolve about a fixed axis of another link. This pair is called as turning pair. So, an example for incompletely constrained motions. Already we discussed incomplete motion means is a turning pair, and complete constrained motion is sliding pair. Next, rolling pair. Rolling means when the two elements of the pair are connected in such a way that one roll over another fixed link. This pair is called as rolling pair. For example, ball and roller bearing. Next, screw pair. When the two elements of the pair are connected in such a way that one element can turn about the another by screw thread. The example, lead screw of the lathe with nut and bolt with a nut. Last one is a spherical pair. Spherical pair when the two elements of the pair are connected in such a way that one element turn or swirl about the other fixed element. The pair formed is called a spherical pair. For example, ball and jocket joint attached of a car mirror. Next, there are two pairs of contact. One is a lower pair, one is a higher pair. First, according to the contact between the elements, lower pair and higher pair. First, we discuss lower pair. When the two elements of pair have surface contact when relative motion take place, and the surface of one element slide over the surface of the other, the pair formed is called as lower pair. It will be see that sliding pair, turning pair and screw pair for the example of lower pair. Next, higher pair. Higher pairs. So when the two elements of the pair have yielding line or point, it's a very important line and or point contact with relative motions take place. This motion between the two elements is partially turn or partially sliding. This pair is called as a higher pair. For example, the pair of friction disc, tooth gearing, belt and rope drive, some example, etc. So examples there. It's a higher pair. So higher pair is a line and point contact, and lower is a surface contact. That's the main difference, lower and higher. Next, according to the type of closures, there are two types of closure. One self-closed pair, another one is a force-closed pair. So self-closed pair means when the two elements of the pair are connected together mechanically in such a way that only a recurrent kind of relative motions occurs. It is called as self-closed pair. It is an example of lower pair. Next, force-closed pair. When the two elements of pair are not connected mechanically but are keeping contact with the action of external force. So we are using for the external force and it is not connected mechanically. It is called as it's a force-closed pair. For example, the cam and follower is an example. It's a good example for closed pair. This is an example of gear. This is a bevel gear. This is animations. The content of two gear is lower bar and higher bar. And right side you content is sliding bar. Is a different of linkage. So one type of mechanism. Next we discuss kinematic chain. So already discussed what is a kinematic. Kinematic is a deals with motion and time without consideration of force. Now kinetic chain is when the kinetic pair are coupled in such a way that the last link is joined to the first link to transmit defined motions is called as kinematic chain. So kinematic chain means it is a relative motions between last link to first link. If each link are assumed to form two pair with two adjacent link, then the relation between the number of pairs forming a kinematic chain and the number of link may be expressed as L is equal to P minus 4. So here P is a pair and L is a number of link. So another relative between the number of link and the number of joint which constitute a kinematic chain is given. J is equal to 3 by 2 L minus 2. Here J is a number of joint, L is a number of link. The above equations are applicable only the kinematic chain. Which lower pair are used. This equation may be applied to kinematic chain. Is a higher pair. Then this higher pair are used in case higher pair may be take equivalent to lower pair with the additional element or link. The example of type of joint. First we explain the binary joint. Binary joint is one of the important keynotes. When two link, link for example link AB is one link, AD is another link, DC link and BC is another link. So there are four links, AB one link, BC one link, CD and AD. So when two links are connected at the same connection, this joint is known as binary joint. For example, for formula express that I j plus h divided by 2 is equal to 3 by 2 L minus 2. Some example is there. Example is this way. The chain of show the figure A, B, C and D is a binary joint link of 4 links. So in order to determine the natural of chain, whether the chain is locked chain, there's a structure or kinematic chain, etc. This following relative between the number of link and the number of binary joint is given. Where J is already we discussed binary joint, H is a higher pair and I is a number of link and H here this binary is joint, there is no higher pair, so H is equal to 0. So we substitute this H value in below equations, we get it the answer. For example, there are 4 links, so L is 4 link. J, number of binary joint, number of joint is 4 joint because A, B, C, D is a 4 joint. A, B and B, C, C, D and A, D is the number of link. So we apply that J is equal to 4 and 3 by 2 into L, number of link is 4 minus 2, so it's equal to 4. So it is a number of chain. Next, ternary joint. The ternary joints, here is a ternary joint. when the three links are joined at the same directions. The joint is known as ternary joint. It is equivalent to two binary joint as one of the three link joint carry in pin for the another two link. Here, for example, show that 6 link 1, 2, 3, 4, 5, 6. There are 6 links A, B, C, D and two binary joint at C. 3 binary joint A and B and D and two ternary joint and C and D, C and E, because the two binary joint to meet the point C and E. So it is called as ternary joint. We are using for the kinetic chain to find out the kinetic chain. Here J, the number of joint is 7 because A, B, D one joint, 1 A, B, C one joint, so total 3. So 3 and C and D we consider two joint. So binary and ternary joint meet. So C and E is considered 2, 2 to 4. So A, B, C, A, B, D 1, 1. So totally 7 joint and 6 link A, B, C, D, E. So we apply this all values here. You get it the kinematic chain. So kinematic chain value is 7. Next, quaternary joint. Quaternary joint. Here, when the 4 link are joined at the same connection, so 4 link, the joint is called as quaternary joint. If equivalent 3 binary joint is generally when L number of link are joined at the same connection, joint is equivalent to L minus 1, the binary joint. Look, that is a quaternary joint. So there are 12 link, 11 link is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 link is there. The joint. And the joint is 15 because one binary joint at D, one binary joint at D, so 1. 4 ternary joint A, B, E and F. So ternary joint we consider for 2. A means 2, B 2, E 2 and F 2. So totally 4, 8. 8 plus D 1, 9. So 9 joint is there. Next, 2 quaternary joint at C and G. So 9. So 2 quaternary joint at C means we consider for 3. C consider for 3, G consider for 3. So 6. So 9 plus 6, 15. So number of joint is 15, number of link is 11. This value is subject in kinematic chain. So we get it, the answer is 15 is a kinematic chain. Here one flow chart is there. One is a link. Next is a kinematic pair. Next kinematic chain. Next mechanism. Next machine. This is a flow chart of how to we consider the for how to make the machines. First link, kinematic pair, kinematic chain and mechanism. Last find the machines. So next, mechanism. Previously discussing the machines, so now we discuss in mechanism. Mechanism, when one of the link of the kinematic chain is fixed, the chain is known as mechanism. It may be used for transmit or transforming motions. So some words, some important words of mechanism. Mechanism with 4 link is known as simple mechanism. Next, mechanism with more than 4 link is known as a common mechanism. The mechanism require to transmit power or to do some particular type of work. is called as a machine. The degree of freedom is a very important thing of degree of freedom. Degree of freedom, if the number of input parameters which must be independently controlled in order to bring the mechanism into a useful engineering purpose. It is a degree of freedom is an independent variable, and it is possible to determine the number of degree of freedom of mechanism directly from the number of link and the number of joint and type of joint which the mechanism including. So the formula for degree of freedom, so n is equal 3 open the bracket L minus 1 close the bracket minus 2j minus h. So here n is the degree of freedom, L means number of link and j means number of joint, h means the number of is a higher band. Next, these equations get the some plane motions. Here, if the 2 degree of freedom of pair, for example, higher pair, we take the higher pair is not given, so higher h equal 0. You put the 0 because it's a no degree of freedom for higher pair. So put there n is equal, this equation will form n is equal 3 L minus 1 minus 2j. Here no degree, no higher pair, so we put the h equal 0. That's all. Next, inversion of mechanism. Inversion of mechanism means when one of the link is fixed in a kinematic chain, it called as mechanism. So we can obtain some many mechanism of number of link in kinematic chain is fixed and different link of mechanism. Next, the type of kinematic chain. Already we discussed kinematic chain. Now we are discuss type of kinematic chain. There are 3 types of kinematic chain. One is a 4-bar chain, and a single slider crank chain, and a double slider crank chain. Now I will explain first is 4-bar chain. 4-bar chain. The simplest and the basic kinematic chain is a 4-bar chain. It's a simple basic kinematic chain. This consists of 4 link. 4 link 1, 2, 3. So 4 link, and each of them form a tanning pair. We consider tanning pair A, B, C, and D. So there are 4 joint. So 4 link 1, 2, 3, 4. 4 link and 4 joint. 4 joint is a binary joint. A, B, C, D is a binary joint. So we consider for 1. So here, so according to Kirchhoff's law for 4-bar mechanism, shortest link length plus longest link length is not greater than 1. Sum of remain 2 link length. This is to be continuous relative motion between the 2 link. In the 4-bar chain, one of the link or particularly short link, it may be a completely relative to other 3 link. It is satisfy the Kirchhoff's law, such a link is as a crank and trigger. Here AD, the link 4 is a crank, and the BC link is a particular lever. For example, BC is a lever, AD is a crank, and CD is a connecting rod, and AB link is a frame. So AB link 1 is a frame, link 2 is a lever, link 3 is a connecting rod, link 4 is a crank. When link 4 crank is to be driver, the mechanism transmit rotate motions into oscillatory motion. Next, inversion of 4-bar chain. Here, the beam engine, the coupled rod of locomotive, and the watt indicator mechanism. This is the inversion of 4-bar chain example. Here, inversion 4-bar mechanism example, beam engine. Beam engine A part of the mechanism of the beam engine is known as crank and lever mechanism, which consists of 4 links. So the link means crank is one link, connecting rod is one link, frame is one link, and last lever is one link. There are 4 links. And joint means there are 4 joints, A, B, C, D, E. There are 5 joints, binary joints. Here A is a fixed center, and the lever oscillates between the fixed center D. And the end of the E of the lever CDE is connected to a piston rod which reciprocated due to the relations of the crank. In other words, the purpose of link mechanism is to convert rotary motion into the reciprocating motion. And next, inverse motions, example, couple, locomotive. The locomotive says there are 4 links, link 1, 2, 3, 4. Link 1 is a frame, link 2 is a crank, link 3 is a lever, and link 4 is also a crank. Next, watt integration mechanisms, another inversions kinematic chain. The watt integration mechanism, which consists of 4 links, link 1, link 2, link 3, link 4. 4 links, the link AC, link CD, and link BFD, it may be fixed. The link A, link AC, and CE, and PFD is a fixed. The maybe is not that PF and FD form one link because it's a ternary joint, 2 parts. You have no relation motion between the link. The displacement of the link BFD is directly proportional to the pressure of gas or steam which act on the indicator dunker. Any smaller displacement of the mechanism, the transiting point E at the end of the link CE truck out approximately in the straight line. This is some point of watt indication. So for any small displacement of transmission, the transiting point E at the end of the link CE trace out approximately a straight line. The initial position of the mechanism, means figure the single sided crank chain A, single sided crank chain. The initial position of the mechanism is known as the figure by fully learned, whereas start line show that position of the mechanism when the gas or steam pressure at the indicator angle. Next is a very important of classification of mechanism based on the mobility degree of freedom of mechanism. Already we discussed the degree of freedom is independent variable position. The consider of the degree of freedom of output only constrained mechanism, unconstrained mechanism. Already we discussed constrained mechanism and unconstrained mechanism. Consider some of the degree of freedom of input and output positions, a single and multi degree of freedom mechanism. Constrained mechanism. Already we discussed the inversion of mechanism. Inversion mechanism is an example of beam, watt indicator, etc. One independent output motion, output member is constrained to move in a particular manner only. For example, 4-bar mechanism, radar crank mechanism, 5-bar mechanism, 2 input. The output mechanism has more than 1 degree of freedom. Example, automobile differential loading, turning the vehicle on a curve. 5-bar mechanism with a 1 input. A single degree of mechanism, sum of the input and output degree of freedom is 2. Single degree of freedom motions, the one independent input motion and another one independent output.